Okay, welcome to the third lecture in this series of video lectures on client server. Again, we have talked about the client server model, which consists of the client, the server, and a network for communications, and the network, of course, consists of a communication link, address, and port number. I've talked about that at length. Uh, Actually, let me, and I've talked about the clients, several servers, clients could be clients. They have port numbers, and each port number is connected to some sockets, and the number of sockets is 65534 or 65535, depending if you count from 0 or 1. And I mentioned that the first 1024 are reserved ports used by the system, and up to this number, these are accessible by users. I already talked about that. And then I started talking about the IPC descriptor, the socket as IPC descriptor. And today I will be talking about the creation, opening of a sockets, reading data, writing data, and destroying a data. Let me start with this. I want to create a socket now on the client side. This is my client side. This is my server side. On the client side, I use this predefined Java class, which is called socket. And I define a new class called my client. So my client is of type socket. So that's what this means. So if I use the comment here, where is my comment? If I use this, so my client is a socket type. Okay, so it's a socket type. Now I want to use this my client. This is what, when I say my client, so I am invoking an instant of this my client. So this is my client here. Then I will use the method new, which means I want to create here, when I say my client equals new, this is, I create a new socket, and the name of the socket is my client. I can give this any other name. It can be my client, could be your client, could be client 1, could be client 2. So this is, when I say new socket, this method, what it will do, this method, it will, this will do, will perform several actions. One, creates a socket on the client side. And this is the socket right here. So it creates this socket. So this green socket, this is the socket that I just created on the client side. Okay. So this new socket, the first thing it does, it creates the socket. And it chooses here automatically, chooses a socket number, a socket slash port number. So we don't know until now what the socket number. We can, in fact, there is a method later on. We'll find what socket number it has chosen. So let's say this could be socket number 5000. It has to be one between 1 and 65,535. This is the first thing. So new socket, the first thing it does, it creates the socket, it connects it to the port, this is the physical port, and this physical port, let's say both client and server are on the same computer. Let's see here. Oops. Okay, do it this way. And let me send this to the back. And let me give this the color yellow. So this is my computer local host. And let me give this the color black so we can see it. Put it up. Okay. So this is my computer. So because both are on the same computer, so my client here, actually, this is, I will call it my server here would be. Okay. So both client and server are on the same computer. So the name, both have the IP address located or recognized by the local host. So now going back to this function, my client equals new socket. So I did with this new socket, I created the socket. I create means I find the location 5000. This is in memory. I will find its address. I will connect that. I will establish a connection between this port and this client. Now this port, as I said in the first lecture, I'm not going to worry about programming this port because this is under the control of what I call the TCP IP. So this is really, it's not my concern here. This is my TCP IP. So this is TCP IP control. So this guy, this port, and this link, the line here, it's not mine, but my problem here is that I create this socket, I call it my client, I hook it to this port, so now it's done. Now the second thing, the second part, which has to do, it establish a connection or attempt, let me see, try to establish. Attempt means بحاول establish a connection with a server located on some machine name. Now because I use, let me duplicate this guy. I'll make another version of this. It's the same thing. but here I will change this to localhost, and I will change this port number to the value 8000. Okay, so here when I say new socket and then I will say localhost, actually this will be one word, localhost, attempt to establish a connection with a server located on the local host, and
Localhost is a host name.
attempt to establish a connection with a server located on machine name, and I would say hooked to port number equal 8000. So this statement, although small, my client equal new socket localhost comma 8000. Generically, it could be machine name, port number, any machine name could be localhost. Now, I can show another example where I would use the IP address, a certain IP address. I will duplicate that in a second. But this is the reason I made this link dotted, because this is attempt. So the client is trying to establish this communication. That's when I said inter-process communication between the client and the server at this port, which is, I found it in the local host, so I'm not going to go to any other computer, and at port number 8000. So this would be my server. Let's say this is 8000. And this one shape. Okay, so this is my server connection. Okay, so this remains dotted until the connection is accepted. Now the connection is accepted means this port, this address is a valid address, and this port number is a valid port number, and the client, in this case, which issued the my client, is accepted by the server. Then a message will come back from the client to the server saying accept. Before I proceed there, I will show another version of the slide. Instead of local host here, I'll change this IP address. Let's say 73.22.1.7. Okay, so this is the address of the server. So this is the IP. Okay. So this is the IP address, and this is the same port number 8000. So this is, now I changed here. I did not. So this is let me. So this is on one computer here. and this one is another computer. Okay, so this is the client on one computer, the server on another computer, and this is the IP address of the server, so I use this one here. Okay, so that's the creation of a socket on a client. Now, for the server, for this to materialize, okay, let me use one more slide. No, not this one. Okay, client to server connection. So let me take this guy here. Okay. Now, so the client here makes a request. This is called a request to connect, by the way. This is a request to connect. Now, if the server is up and ready, and if this port value is a valid port value, no, not here. We are on the local host here. We are on the local host. So I'm requesting, where is this guy? So that's my, oops, this is my request. So I make this request. So this is, with this new socket, localhost, a request to connect to the server, which is on the local host at port number 8000, assuming now the server is up and running. So my assumptions is client makes a request to connect to server at local host port number 8000. Now the server is up and running, which means it's executing. It has a valid port number 8000, and I will show how this occurs. Now the server accepts the connection to the client. It makes an accept. This accept actually is a statement which will be carried again by the TCP protocol. So I'll make this in green and make it thick. Okay, so this is an accept statement. Actually, the accept will come to this place right here, to the port. It has to come to the same port and of course to the same socket. So the client makes a request to connect, the server accepts. After this, now we can say that client is communicating or can communicate with server client using socket. My client is communicating with server using socket. My server. Okay. So this cycle now is complete. There is request to connect and there is an accept. I can visualize that in a more abstract manner. Just IPC representation. I can do that like this. Let me use now these. That's my client. And this is my server. And I would say this is request to connect. I'm not visualizing the sockets here. This is request to connect. And this one is accept. Accept connection. Now, if the client does not receive the accept connection, so this is another scenario. No accept connection. So this does not come and this remains dashed. So this remains dashed if there is no accept connection. Now, because of this, let me go back to my statement, which I started earlier. So if I have, actually, let me put it back here. Oops. And here, when I say my client equal new socket localhost, comma 8000. So if I do print statement system print connection established. So if I have, I'm not sure about the syntax of the system print. If I have the client made a request to connect and the server has responded with accept, and the system will be printed. We'll say statement will be printed. If no response comes, statement will not be printed. And actually, the client will continue to wait forever. And here, client will wait, call it forever. Actually, it's not really forever, but until TCP session expires. It will wait for a certain point of time, then it will stop, and actually the system will break. There will be a problem here. That's why in our system we will use a different way of representing, uh, we'll say socket create client socket with error exception, in order to account for this case so that the client will not remain uh, blocked. We will do this. We will do the following. Okay. We will do the okay, how do I do that? Okay. Catch. Okay. Okay. So this is, so this try my client. Port number. Catch. Okay. Okay. Now, here is the issue. Here is my statement, my client equal new socket machine name port number, and I put this in what's called try and catch, which means this try and catch, if my client, this new socket, is not accepted by the server, just like this example here. Okay, like this example. If it's not accepted, then This guy will wait for few milliseconds. If it does not get the line back, so there is no accept statement, then it will catch IO exception and will print something out, an error. System.out print line. Actually, this is what I was trying to do here. System.out print. Okay. Now, if the on the other hand, so let's on the other hand, if I have okay, if I do have an accept statement, if I have so if I have the accept, then try, I will get out of this loop and I will not do the catch exception. Okay, so my client equal new socket machine port number. This here, the return of this function means an accept statement has been done, and then I will get out. I will not go to the exception error and will not print the error statement. Okay, so that's the creation of a socket on the client side. Now, once you start doing in the lab, you will be testing, you will be playing with this, creating the socket with a server waiting. You will try another time with the server not ready to accept the statement, and you will try once with a try, and you will try another time with no try. So when you don't have no try, the client will hang up and will not be able to do anything. And if you have the try, then you can continue the execution. So you will experiment with these with this actually statement right here, which is the connection between the client and the server. All right. Okay. Now I will keep this here for the echo server. There is an example that I will use with the echo server, but once I introduce the let me see what I want to introduce next when creating socket on server side, and another one write and read right into a socket And there is one more, which is read from a socket. Okay, so these are the next 3 presentations which I will have, the videos. One is to see the server, and then writing into a socket, and then reading from a socket, and then we will do an example. Note that all of these things now I am doing I'm doing all of this on using TCP/IP protocol. I'm not using the UDP protocol. Okay, let me stop right here. This is already 35 minutes. I will stop right here, and I will do the next slide, the next presentation for Wednesday. Okay, thanks.